We won't look as you move your last minute edit.
Yeah, please.
We can't see
Fix that
anything.
typo. Remember. I like the other name better.
Oh.
It's up for debate.
Let's go back.
It's up for debate. All right, guys, so you've got 5 minutes. I've got a sign. I'll give you 1 minute left and time's up, roughly. And then 10 minutes Q&A, which we'll have a nice discussion, and that's about it. So we may interrupt you if we have burning questions, but otherwise just keep going.
Most likely.
Yeah.
Yeah, we'll try.
Chris will interrupt you when he has burning.
Can I get a promise next time?
But
Right.
other than that, ready when you are.
Okay, so good afternoon, judges. My name is Thành Hoàng, a senior in electrical engineering. And here's my friend Trung Nguyen, a senior in mechanical engineering. Today we introduce to you the pesticide spraying robot. But before starting out my presentation, let me just quickly make a statement that pesticide is the best and the worst invention we ever made.
Yeah.
So on the upside, it boosts the yield by 41% compared to the traditional farming technique. Therefore, it makes food more affordable to more people around the world. And indeed, pesticide is a key component to solve the global rising food demand in the near future. But however, on the downside, pesticide cause a lot of health problems for millions of farmers around the world, and mostly lung and skin disease related. By using the conventional spraying method, like shown, there's only 4% of the pesticide hit the target, while the remaining will contaminate water, soil, and negatively impact the ecosystem. Pesticide also create hazardous workspace for farmers. Therefore, most of the young farmers consider moving out to the bigger factory plant, and therefore the labor costs start increasing. Most people might see this as a big problem, but we, as an engineer, we see it as an opportunity. If we spray the pesticide more precisely, we can save extra money for farmers and reduce the pollution level. And what if we can spray it autonomously? This will be triple the operation time, up to 14 hours. And currently in Vietnam, farmers need to pay $15,000 to $20,000 for 2 workers, work over 1,000 meters square per year. So we potentially can sell our robot at $20,000 price with ease. And let me introduce
I apologize, is the 8,000, I'm sorry to interrupt, it was Keith. Is the 8,000 in relation to the 2 workers?
That's the pesticide we can save.
Oh, the amount of pesticides.
Yes.
Ah, I got you.
The chemical.
Okay,
Precise.
so
Yeah,
then,
precise,
all right,
okay.
and then.
And here's our solution. Fully autonomous? No, just kidding, not this one.
Yeah.
We're looking forward to
I'd buy that
future.
one though, it's just for fun.
Yeah, so let me introduce you to Dexter, the Pest Terminator. It's a full autonomous 2-wheel drive battery power with 2 headlights for working in night shift, 3D stereo camera for object recognition, mapping and navigating, GPS and IMU enable, and equipped with a high precision 5 degree of freedom, 3-meter long robotic arm that can reach to many challenging positions. And last but not least, 14-hour battery life compared to any drone and UAV system on the market. That can work for only 20 minutes. And Dexter support for both large farm and small farm. For large farm, we have a retractable hole that's connected to a bigger water tank, and pesticide outside the field weigh up to 2 tons. For small farm, we have a detachable terrain tank that's weigh 16 kilograms. And here's a quick video of Dexter in action. That's the modern solution.
Oh, who pre-programs it to do that? Right, but I mean, every.
Oh, it's
product.
automatically
It's
figured
using
out.
vision.
Yeah,
Oh,
computer
it's using-
vision and
got it,
artificial
got it.
intelligence.
Yep.
For business model, we support for low-income farmer and high-income farmer. We can sell the unit outright for $20,000 unit as mentioned. So it's covered $5,000 to make. And we can support the low-income farmer with a pesticide spraying service. That's cost around $2,000 per month for 1,000 meters square with full maintenance and pesticide supply that we can partner with a pesticide distributor. And For the market in Vietnam, we estimate to manufacture 1 million units to be enough for the market. For the US, that will be 1 billion units and 4 billion units worldwide. That will be a lot of robots to produce. Using the funding of $5,000, we plan on building our first prototype delivered by summer 2019. We already have 1,000 initial customer farmer in Tiền Giang province, Vietnam, who are looking forward to apply this technology in their farm. And as soon as we can prove the technology and deliver the first prototype, our investor will start investing on us and lift the business off the ground. So thank you for your attention.
Nice.
Nice.
Great presentation.
Well done.
How do you know this will work?
So currently in the market, they have an artificial intelligence board that's around $80. It's so cheap, and we can integrate it on the 3D camera of the robot to looking for the object.
What's it
It's so
looking for right now?
The fruit and the flower.
Okay.
So are you gonna armor plate this?
Sorry.
Are you gonna armor plate this? Because there's gonna be a lot of low income people out of work. You thought about it?
The thing is, they not even want to do it anymore.
Yeah.
We run into the labor crisis in my country.
You're gonna have it,
Yeah.
I mean, they're saying that they can't hire people to do it anymore.
Yeah, they just
Yeah.
can't hire
People
people.
just,
So we don't take anybody's
Yeah.
job.
So I've got a couple questions. So I spent a bunch of years in robotics driving around your house, and mobility is a hard problem.
So I use arrow code, like it's a QR code.
Yeah.
So I stick it in the tree, and then it's looking for it to navigate around
So you would tag the trees,
every tree. We have a single
okay.
paper printed.
And when you're driving along, so you got to drive along nice paths. Are you going to guide them along the paths, or are they going to use autonomous driving?
We will have a little tablet, so you
Yeah.
can draw where you want it to move,
Okay.
and at what time in the day.
Okay.
They have similar technology on the farms, you know, when they're doing the water
Yeah.
spraying, instead of
Yeah.
now they're using the GPS systems and.
Yeah, so you use
Yeah.
GPS
And
and,
they can
and
probably-
transponders where you can locally
Yeah.
you can localize easily. But if you go into an unstructured environment,
Wow.
so if you've got ditches or things you got to cross, or if a branch falls down.
Yeah, we
in the
have
way.
a 3D camera to detect
Yeah.
obstacle.
What about the
Just-
airplanes, that,
It just weighs a lot of pesticide.
yeah.
Yeah, we try to run
Okay.
into the big regulation on the usage of
So
it.
you've done analysis to compare mass spraying versus,
Yeah. And by the way, when you use airplane, you just cannot access to the the complex structure of the tree like fruit. It just work well for corn and wheat. Yeah, that's what I'm thinking.
Because it's only falling on the stuff we can see.
Yeah.
Right.
So all the thing on
How
the
much,
root.
so what's the accuracy of this in terms of wasted pesticide? Is it, do you have a sense?
Yeah, it's gonna be really precise because we can approach the target directly. So like, I don't know, like 50% more efficiency.
So it's going to take longer to do the job.
It can work for 14 hours.
Right.
Yeah.
Well, so the videos you showed, you got a guy on a tractor dragging a thing that's fumigating the whole row,
Yes.
and what you're going to do is selectively apply
So
pesticide, right?
For the spraying service we can deploy 3 to 4 robots that working together at
Yeah.
the same time to solve the problem
Okay.
of electricity.
Yeah, but I think to your point, right, the brute force method they're doing is fast, but it's
It's just a lot of
inefficient.
waste.
So now
Wasteful and not healthy.
to be more efficient, I'm assuming it's gonna take more time or more robots, right?
Yes.
So I guess that'd be something interesting for the future if I was doing this, like, hey, I'm gonna replace this one automated machine or 2 humans with this, and what's the trade-off here? Because I'm assuming it's not gonna do it as fast.
That's right.
Right.
You just do the same with the.
So do you need
human.
14 hours to do 5 hours worth of person's work? Is that what it
Yeah,
is?
that's a good
I
question.
think
Yeah.
I would say that one robot
Yeah.
can work as fast as one person at a time. So because they are moving really fast nowadays, we have
Okay.
really good technology on modern things.
Okay. And in your calculation, one of the things you ought to include is that although Army of Robots is going to require people to upkeep it, right? It's a higher
Right.
skill thing, but you're going to need somebody to maintain robots, and because they're going to break down every once in a while, and you're going to need somebody to maintain the environment so that the robots can drive.
Right.
there. So you're not getting rid of, you're getting rid of, you're substituting for a lot of low-cost labor and inefficiency, but there's also, there are hidden
Added,
costs, right?
Yeah,
So
a
watch out
consideration
for,
of that total cost of
Yeah.
ownership, I think is something that.
watch out for your hidden costs,
Yeah.
okay?
Yeah.
So you're the mechanical guy.
Yeah.
What kind of arm are you gonna use?
Um,
Are you making your own arm, or are you gonna use somebody else's arm?
Yeah, we're gonna look to make our own arm, and we're gonna put all the motors down at the base to reduce the load and at the same time increase the speed that the arm
Okay.
can move around the space.
And how much comfort do you need for doing trees and things? Do you need a big reach?
Yeah, kind of like.
It's gonna be
maybe
like
up to
3 meter, and the nozzle can spray up to
Okay.
2 meter.
Okay.
Yeah.
So
we
where are
have
your
5
chemicals?
meters.
Where are you chemicals? I mean, you're gonna need vast amounts of chemical. Are you gonna have basins that are gonna be set up that this thing's gonna fill? Is this machine gonna go, have you thought about that yet?
Yeah.
Oh no, they have a retractable hose that's connected to the water
So you're
tank.
gonna be running hoses
Okay.
all the way out with it continuously?
And by now, farmers still doing exactly the same thing like us.
Okay.
Mhm.
That's how the humans do it.
Because they don't want to carry a backpack full of pesticide.
Right,
And are you the vision guy? And how much vision work have you done, like detecting different things?
I'm finishing out localization, like mapping the tree and doing navigation around the farm.
So localization and mapping.
We use the QR code there.
Okay, yeah, so you do that, but,
And
but are
GPS
you gonna pick when you've got a tree, you said you're gonna pick the fruits and the flowers?
Oh yeah. So that's we will apply the technology of Google using right now is TensorFlow for object recognition.
Okay,
Interesting.
cool.
Yeah.
Very good
Yeah,
job.
have you
Yeah,
thought-
all thought through.
I have one
Graphic
question. I have one question. So have you thought about the IP side of things? And I say this, I know that you're not expected to know it 100%, but we also have a lawyer in the room that
So
will
we
be able to
find
give you.
one of the best thing we can find on the market right now. It is just only work in the greenhouse.
Say again?
They have a robot that can only work in the greenhouse.
Oh, the
Greenhouse.
greenhouse.
Yeah, so I think, so I think to answer the question, this automation robot would be patent protectable in multiple ways, so
Yes.
you should see
More
patent
yeah, we
complex
should
protection.
do that,
environment.
yeah.
You should seek that protection before you discuss it with many people. Right, you don't, because once you divulge it, it's first to file, right? So.
Yeah.
Right.
But I will say that we've had a discussion, and that's my advice, and this, starting now is, I had him look for
Yeah,
IP.
especially because the other reason not first to file necessarily is for foreign protection, when say foreign, outside the US. So if you publicly disclose now, we don't know all the guts of the invention, but say you publicly disclose, you have 12 months to file in the US, but outside the US, you lost most of your rights. Most countries don't have a grace period.
Yeah.
So, especially when you go into Vietnam or considering, other type of countries like that, you're gonna wanna file so you can patent protect those countries eventually.
Thanks.
Excellent job, guys.
Excellent.
Nicely done.
Thank you.
I like the visuals too.
Yeah.
The animation.
They were
Very
good
good.
visuals, they help convey a lot of the idea.
Presentation was well done.
Right.
Yeah, very
Good
well
work,
done.
guys. Thanks.
Very well
We'll see you soon. Nice to see you.
Thank you,
again.
gentlemen. See you later.
Good work.
Thank you very much.
Good job.
Right, thank God.
I wish we were that smart when we were in school.
Yes, we were, we just didn't have
Yeah.
any technology.
We just didn't have
work.
difference
Speak
maker.
for yourself.
We didn't have difference maker.
We had Capstone.
Oh, there you
Yeah,
go.
we had the
There you go.
Capstone.
Well,
Although we didn't have capstone, did we?
we didn't,
Didn't you have
we
it?
didn't
I
even
had
have the internet, for God's
No,
sake.
no,
have
no, we
capstone.
really had a
You
PC,
didn't have a
no, we no
capstone for us?
capstone.
I had it. We had our Capstone was Stanley Garage that wrote it. We developed the screw.